All right, today we're going to be looking at how we describe the shape of a graph that represents a data set. So we're going to have three main descriptions for the shape: uniform, symmetric, and skewed. A uniform distribution is when we have all the data values have the same frequency levels. So this dot plot's a great example. We have 410s, 420s, 430s, 440s, and 450s. This would be perfectly uniform. And we know that the representation, if you look at the data, is a horizontal line because all the frequency is exactly the same. Now, I did say or close to the same frequency. So this histogram below, you can tell that they're not exactly the same, but everything is pretty darn close. So if I go across this top of the histogram, it'd be close to this pink line. It's a little jagged, right? But it's pretty darn close. So we'd still say that's a uniform distribution. A symmetric distribution is when you have a clear middle and the left half is a mirror image of the right half. So this is a perfect, this little bell-shaped curve here is symmetrical. Here's the middle. This middle would represent the mode, the mean, and the median would all be about right here in the same location if it's perfectly symmetrical data. Again, we'll be looking at different examples here. Sometimes it's perfectly symmetrical, sometimes it's just pretty darn close, and we still call it symmetric. So let's take a look at some. Here are two dot plots that represent symmetrical data. So you can see it's very balanced. The average age of tennis players in years. The lowest is 25, and there's only one person is 33. Two are 26, and two are 32, and it just keeps going like that and balances out. You got a pretty big middle here, almost a uniform center, if you will. But that would be an example of symmetrical data. If I went to draw on this, right, you can kind of see it goes up and then it comes down. It's not the prettiest graph. And the same thing here, right? It goes up, peaks here, hours on the internet, and comes back down. So it's kind of that symmetrical shape there, if you will. Here's an example with the histogram. So I can draw that bell curve around this histogram. It balances out each side here. We got these two bars in the middle. If I was going to identify the middle octane for the gas, it'd be about 91, right? Would be my middle, 91. Here are two box and whisker plots. So we got a number of visitors at the state park, right? The median is 50. Your Q3 is 70. Your Q1 is 30. Those are both 20 away from the median, right? Very balanced. You got your max is at 90, which is 40 away from the 50, and your min is 10, which is 40 away from the 50. That's perfectly symmetrical there. Science test scores. So 80 is our median. The max is 120 away. Q3 is 90, which is 10 away from the middle. Your Q1 is 70, which is only 10 away from the middle. And then your 60, your min, is 20 away from the middle of the 80. So again, that's another example of symmetrical data with a box and whisker plot. Now, a skewed distribution is when you have more values spread out on one side versus the other. And the side where the values are more spread out, that's the side we say is skewed. So it's going to be either skewed to the left or skewed to the right. So if you look here at the skewed to the left, we have a number of values. The lower values are more spread out. The upper values, the higher values in this data set are more clustered close together, right? So this would be skewed left. You'll see a tail of the curve. It goes to the left. Skewed to the right means we have more values clustered in the lower range for that data set, the lower numbers in the data set, and you got a few high values, So the tail, if you will, it goes to the right. So this is skewed right. You see the term outlier. We're going to be talking about outliers today. That's just going to be a value that's really far away from the center of the data set. And we're going to define how far away that is to be called an outlier later. So here's a dot plot example of skewed to the left. So you got a number of text messages sent today. You got a big cluster here, and then it kind of gets spread out. And it's not always a perfect tail, right? It kind of goes up a little bit like this and down. We'd say this is still slightly skewed to the left. Here's another dot plot, number of siblings in the family. So you have a lot of families with 0, 1, or 2, and then the larger families are not as many. So this is skewed to the right, where there's only a few with 4 or more. Those are spread out more versus the cluster here of families with no siblings or 1 sibling or 2 siblings and so on. Here's a histogram. And so here's another way to think of it. Ski slope to the left, right? So up, and then it comes down, 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 down like this. This is that tail or the big slope of the ski run. So that is skewed to the left. And then we can look at another one example where it's now skewed to the right. So here we have some line that goes up, 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 up. And then we can see how this kind of tails down this way. This would be skewed to the right. So this example of histogram where that slope is on the right side of the data set. Another way I think about the middle of the data set, somewhere around here, right? Somewhere in here is the middle. And you see the spread on the right side of the middle is much larger than our spread here on the left side of the middle. It's more clustered close together. That's another way of thinking of which way it's skewed, right or left. Here's an example of a BoxWhisker plot. So we know our middle is the median, is the 160. You see how the right side, everything's clustered pretty close from 160 to 200. On the left side, you see how it goes from 160 all the way here to 40. It officially goes all the way to 20. This little asterisk here, that's going to represent an outlier, which we'll be talking about soon. But you can see the data is much more spread out here on the left side, going from the 160 all the way down to 20, versus the upper half of the data set, which is only going from 160 to 200, clustered closer together. Half the data set's between 160 and 200 versus the other half being spread out from the 20 to the 160. So this one is skewed left. Here are a couple examples of BoxWhisker plots skewed to the right. So here's distance of flights. So your median here is 600, and this is skewed to the right because you have a bigger spread of the data, right, from the larger distances, right? The middle half of the data goes from 600 all the way to 2200. And again, that's an outlier out here. If we take out that outlier, it still goes from 600 to 1200. So it's a spread of 600 versus the left side, which we're only going from what, 600 to maybe 300, spread of 300. So it's a lot more flights that are shorter distance clustered together than the larger flights. On this right side, donations to charity. So the median is $80, and the range here on the left side, left half is only 40 to 80, so that's 40 total. But on the right side, it goes from 80 all the way up to $220, right? Again, this is an outlier, but even if we took the outlier out, we're going from 80 to 160, so that's a spread of 80. So this half, the data is spread out a lot more than the left half. So we'd say this is skewed to the right. So in closure, these are the 3 terms we're going to use when we describe the shape of a data distribution. We're going to say it's either uniform, it's symmetric, or it's skewed. And when it's skewed, you'll say skewed left or skewed to the right.